Okay, you guys. Should have your packet out. Not going to wait. The packet we were working on yesterday. We are on 29. Okay. Okay, you should have your packets out. We're doing this problem. This is fair game. Okay. Noah, James. Now, Jack. You were not forever immortalized on my video. Not yet. Okay. That should look familiar to you. It looks like this. Alexi, I need you to settle down. Okay, this is it. Now, those of you who don't pay attention in class today, don't come in for help tomorrow. Because this is your time right now. I don't mind giving you help if you need more help than what we do in class, but I'm not going to repeat myself. Okay, do you recognize the purple statement? What is it? It's a derivative. This is how they're going to get the definition of a derivative on the exam. Now, it's possible they might ask you to use the definition of a derivative, but I don't even know what that trig identity is for the tangent of 3 times x plus h to do the problem by hand. So instead, I'm going to recognize what's my function. It's the tangent of 3x. And they're asking me to find the derivative of that. Well, what's the derivative of that? Secant squared of 3x times 3. They didn't give us any values, so that's answer B. That's the answer. Because I recognize that this is the derivative of some function. What function is it? It's right here. There's nothing to solve. We're finding a derivative. Could you use the trig identities if you knew them? Yes, and trust me, that one's not fun. That's a quotient. Tangent of the sum of two angles. Can't do number 30. Can't. I can. Okay, phones should be put away. You can text your friends later. Okay, let's do the next problem, which is 31. And there's a lot of pre-calculus questions on here. That's what this is. Okay, you guys, if you're going to chit-chat like that, we're not going to get through it. That's the reality. This is f of x. And we want to find f inverse of x. Now, if we wanted to find the derivative of the inverse function, you have enough struggles just getting the inverse. It would be easier to use our theorem. Now, there's no examples on here of the theorem of doing the derivative of the inverse functions. So you're going to have to go back into your book and do those problems. That'd be the best thing to do. We'll see if we have time. No, it's 360, 310. But you have to know the derivative of all the trig functions, which was in 3-4 or something. The emphasis is on the second half of the chapter, but I can't separate out the other things. Just doesn't work. Okay. Here's a reason why. Sophie. Yes. Huh? Well, it's whatever it is, but we still have to know the trig. Yes, that's the cosecant of x. The derivative? Yeah. Negative cosecant of x, cotangent of x. Now I can do little Quizlets and put them up online, but that's a pain. Okay, come on, you guys, so we get this done. If I wanted to find the derivative of the inverse, you have enough troubles finding the inverse. Nope. Inverse of sine of x is inverse sine of x. Sine to the negative 1 of x. The reciprocal of the sine of x is the cosecant. This is the inverse function, which means that the sine of theta is equal to x. This is the reciprocal, which means 1 over sine of x. And notice they're not the same things. Inverse sine of x is the angle whose sine is, whereas sine of x to the negative 1 power is a reciprocal of whatever the value. Now, the sine of x is just a fraction. It's just numbers. X is my angle there. So it's totally different. Okay, so to find the inverse here, we switch x and y. So x equals y over y plus 1. And what I like about math is it tells me what to do. Think of what am I going to do? What's the only thing you can think of to do? Right. Multiply by y plus 1 or cross multiply. Noah, what do I get? I get x times y plus 1 equals y. Some of you are just really lazy about your parentheses, and that gets you in so much trouble. You must distribute, because I'm distributing multiplication over addition. So plus x is equal to y. And now I want to solve for y. And you guys, we've done this with dy dx. It's no different. We got to get the y's on the same side. Because why is it we can add 5x and 3x? I know we told you that it's 8x. You just add the coefficients. But why can you do that? Because if you factor out the x, you're left with 5 plus 3. I know how to do that. So if I get the y's on the same side, not dividing, what's the opposite of adding x? Minus x. And then I can do this. Factor out the y. You could have, because we have to match it. It doesn't matter which side, but the problem is I have to be able to match it. Now, I can't take 1 away from x. If this had been a 3, then I could do it, just like if I had this. But it's the same as the dy dx thing. It's no different. We divide by x minus 1. Same concept. Divide by x minus 1. So y is equal to minus x over x minus 1. What if I reverse the x and the 1? What if I make that 1 minus x? What happens to this negative sign? Okay, now you can match it. And when I match it, it is C. Why did I do what? Yes. Nope, I have a y over here. You have to get all the y's alone. Let me put it this way. If we had, okay, you guys, if you had this, you don't have y by itself, do you? What would you do? You would subtract 3y. Yes, you do. And so you get x equals y minus 3y. And, you know, you can do it, it's negative 2y, but you can do it because of that. Because you factor. Hmm? You don't get what? I just put the y's on the same side. I should have just put this over there, and then I would have ended up with that answer right away. But that's okay. As long as you switch both the denominator and the numerator to their opposites, yes. I don't know. I just know the answer happens to be C. Well, it's not a lambda, but that looks like one. It's not really a lambda on the answer sheet. Yeah. It's multiple choices out the choices. So they're the same kinds of questions. They come off the AP exam. So if you've done this and you do your homework, you should be in good shape. There's no derivatives of inverses in this packet. There should be, but there aren't. This was probably the year it was in the free response. Of inverses, yeah, that's 310. Okay, should we do 32? 32. I'm going to go through all of these because you know what? If I have y equals the sine of x, what's the period? How long does it take to repeat? That's the period. 2 pi. Okay, so A is probably the hardest one to deal with. So f of x, but you should check them all because they might be in a different order next time. 1/2 x. And what I do, this is how I do it, I know that the period of just the sine of whatever the angle is 2 pi. So I make 1/2, and there's the period, is equal to 2 pi. And I solve for k, and that gives me the period. That's just the way I was taught 80 million years ago. 4 pi. So that, and if you could think about it, this one is being slowed down. So it takes twice as long to repeat. Noah. So it's A. What? K is the period for my new one. That's just how I do it. You guys learned it a different way, but I do this because it works every time. Now, it's 1/2 of the period has to be 2 pi. That's the period for this function. It just gives me, I know that my angle will repeat every 2 pi, so I solve for that. It's 4 pi. No, this is a period of 4 pi. This one, you guys, what's the period for this one? That's pi. Here's the way I think about it. Here's the sine function, and this one's going to go through twice as fast. So it's going to get through the whole cycle there, because it goes twice as fast. This is half as fast. So this one gets dragged out. Now, but we better look at the other ones just to make sure we understand them, because it might not be this way. We will. Okay, you guys. B. Absolute value of the sine of x. Well, I've already written on my sine function, so I better draw another one. All it does is flips the negative to be positive. So what's the repeat? It's pi. Okay? It says which one's not pi. Sine squared is similar. It's not going to look quite like this, but it's still going to have this piece that's squared. It becomes positive, which is identical to that piece. If you don't believe me, graph it. The tangent of x, you guys remember what the tangent looks like? You should know these. There's pi over 2 minus pi over 2, and so that's equal to pi. And now the tangent squared, by the way, tangent looks like this. And so the tangent squared is something similar. This gets reflected over this. There's the tangent squared. There's the tangent squared. What's the repeat on this? It's still pi. Okay? It's still this length here. Sloppy, but it's there. Now that's not a calculus question. That's a pre-calculus question. No, you don't. Okay, let's turn the page, because guess what? The next one is a pre-calc question. Who wants to come and put this on the board? You get a sucker. I'm doing it today. Yes, you did. You got it right. Okay, Jack. Yes, how many have I got here? Okay, how do I find the zeros? Is that calculus? The zeros? Didn't ask for the derivative being 0. It says find the zeros. Okay, we're not going to do any guessing. You guys, today is the day to work on this, because if you can't do it today, what makes you think you can do it tomorrow? Nothing. Okay, is e to the x ever 0? Here's e to the x. Never 0. What about e to the minus x? Okay? Those are always positive. We're going to run into those in chapter 4. Now, this is never 0, so you would look for more e to the x is 0, but that doesn't happen. So now you look for the sine of x is 0. It's the zero product property. Well, that's easy. I'm going to draw the picture. Only 0 to 2 pi. So it's 0 here at 2 pi. It's 0 at pi. And it's 0 at 0. How come you didn't want to come up and get a sucker? How many zeros do you see there? It's got to come up. Pardon? This is zero product property. Either e to the x is 0, or that's never 0. Okay, ready to do 41? I'll have you guys come up and do some of the derivative stuff, because these you have to talk about. This is just a review of limits. That's pre-calc. Okay, ready? Now, we're preparing for the exam as well. I've only got 5 weeks. I mean, it sounds like a lot, but 5 weeks. You got to know it before then. 5 weeks before the exam is when you make it solid. So you got to really work on knowing it now. Now, and I can't remember to tell you everything the week before the exam, but the first thing I'm going to tell you about this as I read the question, because I don't have time to go through, and all I got are 4 multiple choice exams, but I don't have time in class to go through all 4 exams. That is our weakest link, by the way. You do well on the free response. We need to focus a little more on multiple choice. Okay, guys. It says, which of the following must be true? And if it must be true, it has to be true all the time, Noah. All the time. So, just because the limit exists, don't just look at it. Go through it step by step. I'm going to draw a function where the limit exists at 3. Is it continuous? Does it have to be continuous? No. False. Which ones must be true? Now, if it's not continuous, can it be differentiable? No. Because this fails, this must also fail. It's not C. Okay. I don't know. It says which must be true. I don't know. No, not necessarily. Can I draw a picture where it's not continuous? Yes. Therefore, I can't say it must be continuous. Must means there are no breaks in the graph. Differentiable means that you can find the derivative. Well, there's a picture right there. Is that continuous? No. If I go down 41, they put the bridge in. F of x is any function. No, that's y equal 1 or something. No, this isn't. Okay, guys, you got to read it. This is not saying f of x is 7. It's saying as we get close to 3 in our function, that the y value is getting close to 7. So, do I know for a fact that the function is 7? No, it might be, but it says must be true. So you know what? If it's not, it could be true. It could be true, but it doesn't have to be. So none of them have to be true. Is that continuous? Can I draw this and get to the other side without picking up my pen? No. Because there's no, this does not tell you that it's continuous. This just tells you that the limit as you get close to 3 from either side is 7. It didn't tell you that. The question is it differentiable? Well, if it's not continuous, can it be differentiable? Emily. Otherwise, you have way too much work.
What is differentiable?
Okay, you guys? What's differentiable? Madeline, put your phone away. You can find the derivatives. I'm going to send an email home to all the parents and say, watch this video and see if your child's named. Yeah.
I haven't been named yet this year. I've been doing good.
Oh, yes, you have. No, there's no asymptotes for log. Okay.
Oh, I thought it was just white.
Okay, number 42. If you want to get through this, we got to get through it. Okay, if it says y equals 1 is an asymptote, it means you can find the derivative. That's right. If it's not continuous, you can't find a derivative. Okay, guys. Alexi. James is going to be next. Okay. What does this mean, y equals 1, as an asymptote? What kind of asymptote is it? It's a horizontal one, right? And you have to remember horizontal asymptotes are the limit as x goes to infinity of my function has to equal 1. So now we're going to look at the graphs here. How about the log of x? It doesn't go to infinity quickly, but it does go to infinity. Like the log of 100 is 12. You have to go way far away from the origin to get there, but it eventually does go to infinity. There is no horizontal asymptote for the log function. Okay, B, how about the sine function? Now, remember what a limit is. It goes to a single value and it stays there. What's the sine function look like? Does it stay at 1? It's not to say it doesn't, that it does get to 1, but that's got nothing to do with it. It does not exist. There is no limiting value on the sine function. So it doesn't exist. Okay, let's do the limit as x goes to infinity of c. X over x plus 1. Now, people won the lottery. In fact, somebody won here in Minnesota, I think, 100 million, which is really not too bad of a consolation prize for the lottery last night. 100 million. Yeah, I know. Not in Minnesota, Arizona, and someplace else. 2 places. Maybe. Okay. Every year says that. Okay. No, I'm not lucky at all. You have to be lucky. No, I'm not. Okay. How about this one? So if I had won the $100 million, do you think that the 1 matters? So this looks like x over x. What's the limiting value? Now, why is it not d? Because d is the limit as x goes to infinity, that's right, of x squared over, is it x plus 1? X minus 1, who cares? Well, that, again, I don't care if they take $1 from me. That looks like x squared over x, which is going as x, so that actually goes to infinity. We have 2 kinds. A horizontal asymptote is the limit as x goes to infinity. Vertical would be as x approaches 1. Why do you think they put D in there? Because it says y equals 1. If they had done x equals 1, then D would have been the answer. Glad I thought about that. Guys, what does e to the minus x look like? Looks like that. Its limiting value is 0. Okay, ready? The answer is C. Okay, now we can get some student volunteers. No, I said students. Yes. Okay, who's going to do this? Okay, you need this to get out the door. Okay. Who's going to do this? Come on. Okay, you got to do the work. It's implicit. Okay, she brought the 10 over. She didn't have to, but she did. And then she takes the derivative, 2x. Then you have to do the product rule on x times y. So it's x times the derivative of y with respect to x plus y times the derivative of x with respect to x. The derivative of 10 is 0. And then I said, go ahead and put in 2. And then everybody says, well, how do you know what y is? Well, you do know what y is. Because once I know what x is 2, I can solve this equation and get y equals 3. And then you put it in and you solve for dy dx. Because x is 2, so it's 4 plus 2 times y equals 10. So subtract 4 from both sides, so 2y equals 6, y equals 3.
It's actually 7 now.
Where did what?
Sorry, but scroll down. It's actually 7 now.
Negative 7 halves. No, it's negative.
Why does she have negative 7?
Halves. She's got halves.
It looks like a 3.
Looks like a 2 to me.
Product rule.
You have to use the product rule. So 2x, x times dy is 2 times dy plus y. Y is 3. This would be a negative y. You have to figure it out. X is 2. And you put it right in here. Whoops. And then you put it in there, and you solve, and you get y equals 3. Going on. Now, we're not going to get through as much as we did second hour, but you can look at the solutions. So if you look at the review for day 2, that's where it'll be. I really like problem 8. But you have to think a lot about problem 8. Are you ready? It's a tough one. 8's hard. Well, okay, first reason why it's hard, or waiting, is there's a lot of words. That's the first reason. Second thing is then you have to interpret what those words mean. Can I switch the... Okay, so number 8. This is a different exam. It says f and g are differentiable. What does that mean? Okay, so you can find the derivative. And it has these properties. And the first property is g is always positive. Now, here's the symbol for all. It's an upside down A. Math people have a lot of symbols. The symbol for, it says f of 0 is equal to 1. This means for all. It's a math symbol. Okay. Now, they tell me h of x is, and I don't like all those x's in there, it's f times g. Product. Then they tell me that the derivative is f times g prime. I'm just copying this problem because I like to see it up there. Right? Now, they tell me that for this function, that the derivative of h is just f times g prime. Well, we know that h is equal to f times g. And now if we have any function there, okay, Noah, what's the derivative of h? It's f times g prime, product rule, plus what? G times f prime. But they told me that h prime really is f times g prime. That tells me a lot. What does it tell me about that? That has to equal 0. Okay, so either g is 0, or f prime is 0. But they told me that g was not 0. Okay, but we still have a little more thinking to do. Are you seeing the sequence of my thinking? Okay, just going in order. So if the derivative of some function is 0, then what does that tell you about the function? It's just a constant. And they told me what the constant was, because they didn't give you extra information for nothing. They told you it's 1. So what's f of x equal to? f of x equals, sorry, not 0, equals what? Copy that part wrong. Now, this was, it's not, f prime is 0, not f. Sorry, I just copied it wrong. Don't know why I was thinking that way. So the answer is E. I did almost everything in my other class. If I don't get through it all here, you'll have to go and look at my other class's PDF. It's right there. There were all the classes are always doubled up. Period 2 and period 3. Okay. We skipped number 9. It is when you know what it's asking. But number 10, we need another student volunteer. Number 10. This is an instantaneous rate of change. Well, it doesn't matter. Somebody can do what they want. And x is equal to 2. When they give me the value of a variable, I'll do my derivatives, but I'm going to put it in right away after I do derivatives. Okay, who wants to try this one? And everybody should be able to do this. You've already been up there. No, it says, I want the instantaneous rate of change. What's it asking for? Only thing you know about, which is the who wants to take the derivative of that? Right? Yeah, that's all it is. Who wants to do it? Oh, everybody should be able to do it. Do you want to do it? Yeah, this is the Lodi High. Noah. That's why you switched. That's why you switched places. What? Denominator times the derivative of the numerator, which is 2x. What's the derivative of x squared? Because this is the derivative of f over g. Do you remember the quotient rule? So it's the denominator times the derivative of the numerator. Minus, because I can. They do give you some bones. They threw you a bone on this one, right? By chance. Totally by chance. Yes. Yes, you do. I don't like that. They try not. Now this one, if you just put it until you get the right answer, that's by chance. They try not to do that. They try to, yeah. Okay, 11 we can't do. 12 we've done before. It's been on your test. You always have to know about limits. What can I say? But this is easy. Matter of fact, this was on your partner test. Okay, guys, speckling. Now, I want to find the limit as x approaches 2. First question is the log function continuous everywhere? Everywhere in its domain, that is. Yeah. And guess what this is? X squared, Alexi? That's just a parabola with a coefficient of log of 2. About 0.7. Okay, guys. So how do you find a limit? Alexi, how do you find a limit? The limit from the left has to equal the limit from the right. Do you want to come up and do it? What's the limit from the left? I use the top equation. So it's the natural log of. Yes, but what's my x? It's 2 from the left. It's 2. From the right, the question is, are they the same? This is 2 squared times the log of 2. They're saying, does the limit exist at 2? Well, does it? No. Some of you didn't like this problem because you said, I don't know what the log of 2 is. You know what? I don't care what the log of 2 is. Those are not equal. So it does not exist. So it's E. You always got to go from the left and right. No, I have a church thing I have to go to. I do all my study sessions in the spring. Well, I have a church thing tonight. Plus, I was supposed to be going to a webinar too, so I can't do that. Webinar. Anybody could do the webinar, by the way. But it's on a, yes, if he has an Inspire Cast. It's on calculus tonight. I wanted to see it, but I'll have to see the video of it. I can't. I got to go to do my church stuff. Okay, ready for this next one? Okay. A question. Now, you guys, you have to read this. It says the graph has a vertical tangent at 2, 0. That's vertical. And it says it has horizontal tangents at 1, right down here. There's a horizontal tangent, like I care. Okay. It says, where is f not differentiable? Well, I don't have differentiable functions where? When there's a break in the graph. So at x equals 0 is a problem. There's another one, though. At where? Okay, James, you're not going to know this. It's at 2. Because a vertical tangent, what's the slope of vertical tangent? We say it's either undefined or we say it's no slope. So the answer is B. The derivative exists. You can find it. You can find the derivative.
Wait, stop, wait.
The derivative of 2 is 0. You can't find a derivative at a jump, a sharp corner, or vertical tangent. Those are the 3 places. So any point of discontinuity is a problem for derivative. Yes, that's the sharp corners. What's 0? It said the slope here was 0. I think they said the slope here was 0 too. Yeah, they did. They said it has a horizontal tangent.
Oh, what is happening?
If you have a horizontal tangent, what's the slope? What's the slope of that? Okay, sharp corners like absolute value and vertical tangents.
So I don't get how those are not differentiable.
It's not differentiable here because the function, where are you going to take the derivative? Here or there? And the derivative from the left has to equal the derivative from the right. Can't do it here because the slope is undefined. At 2. So this is it.
Yeah, I don't get that.
You just can't find the derivative at those 3 places. How about number 14? 14, my position is t squared minus 6t plus 5. And it says find the value of t where the velocity equals 0. How do you find the velocity? dx dt. You want to come up and do that one? Okay. And then we're going to do 16. 17 you can't do. So cross out 17. You can do part of 17, but we won't deal with it today. So we're going to do this one and 16, and I think by then we may run out of time. Did you take the derivative? What is it? Yeah, where is that 0? Where is that 0? Answer is there. Huh? Where is it 0? No, when is the velocity 0? When is this 0? This equals 0. There you go. There you go. You're going to do 16?
Oh, I thought.
Do we need to see 14?
No.
16 you do need to see. What's the derivative of e to the x? E to the x times the derivative of that exponent.
So it's going to be -1, so negative e to the.
Yeah. So this is t equal to 3. You need to see it. We'll have somebody come up. Who wants to do this one? It's a matter of really writing this down. Now, I discovered in my other class, okay, Alexi, guys, listen carefully. I looked at this one, the other class, they think it's the sine times that. That is not the products rule. E to the minus x is the angle. Who wants to come up and do it? Come on up. Try it. If you can't do it today, you can't do it tomorrow. This is our last one. Now, we did do 18 and 23 and 28. We're 3 problems short. They are on the smart board for period 2. It's not times. It's not a product. No. What did you say? E. Oh, okay, I thought you said B. Well, watch. Hey, guys, sit down. You should do them all the ones you can. But there are 3 I missed. Yeah. I did everything but 3 of them. Okay. Okay, guys. I've got the cosine of e to the minus x. Now, chain rule. Stephen, Zach, have a seat, please. As soon as we get this done, we'll leave. Okay, guys. Times the derivative of e to the minus x. Parentheses. And then which one does that match with? E. Okay. Time to go.